Then hydrogen conversion, you can have the storage, transportation hydrogen. So people talk liquid ammonia. Now LOHC are also coming up, right? So that is required. Compression, transport, that's very, very challenging still for hydrogen dispensing. Hydrogen energy, fuel cell versus right on mobility systems, when you talk about what kind of fuel cell will require very pure hydrogen. So that is again a challenge for the future. Safety is very, very important. So training here is very, very important. So we need to find out the capacity building programs for utilization of hydrogen, whatever form of hydrogen is there, because regulatory frameworks for all fronts, whether it is for vehicular application or for mobile or stationary application, we need to find out the solution for this. And finally, the manufacturing storage of hydrogen, carbon composite cylinders. So huge opportunities are there if you look at, right, to work on the hydrogen based, right, devices, whatever the feedstock for hydrogen production. So technologies are available at different levels and we need to take it, but biomass pyrolysis is not matured for the hydrogen production. Biomass pyrolysis, bioliquid is already at matured stage, lot of work is being done, but biomass to hydrogen is a challenge. For that we need to take the technology to the TRL level 9 so that it can be converted to the industry, right, or for the commercialization. For rest of the things also you see that if you look at the coal, all these technologies are matured. Even water electrolysis is not at mature because it is very, very costly as of today. And when you talk about nuclear usage for hydrogen production, it is only at infant stage. So we need to look forward the other technology also, but this is one of the ways by which the, right, we can utilize the resources effectively for the future. So at conclusion, when I say, right, I just to put some points here, that we need to understand that can biomass be converted to hydrogen. We need to find out the support from the different industries and the DST or CSR bodies, and we need to find out a kind of decentralized manufacturing and consumption which can eliminate and reduce the transportation, because this is a big challenge, the collection and segregation of biomass and utilize it for that, what biocoal or whatever, that torrefaction. So that is a big challenge. So we need to find out the solution. And also carbon dioxide which is coming, although the techniques are now available. So carbon dioxide efficient utilization when you use the biomass, that is also very important, because we talk in terms of green hydrogen, otherwise it will become a blue hydrogen. So CCUS will play a big role here. Economics is to be calculated, and we need to develop technologies like CCUS for net zero, and already a lot of work is being done in these areas, and mature technology are there. So most important thing what you see, if you look at 25 million ton of hydrogen, right, production which we, right, envisage, right, whatever the kind of feedstock, so 25 million ton of hydrogen means 75 million ton of the crude oil. So this 25 million ton, right, the biomass availability is there for this. And even if you don't, only 10% of this is from biomass, so 25 million is equivalent to 75 million ton of crude oil. 25 million ton means 100 gigawatt of the electric, right, equivalent. That's what the advantage. And 25 million ton means 800 million tons of the carbon dioxide you are capturing. So that is where the advantage of the green hydrogen which is required, and this can happen, right, only with the renewable biomass, right, which is, you can use the biogas also, methane which will come and convert to hydrogen. So these kind of, I think there is a need to work in these areas, and we need to find out the solution. So way forward, we need to build a mission level, right, programs at different fronts, collaborate globally, right, within the academic units and along with the industry. That is also need of the hour. Support is required from financial funding agency, regulatory policy, all these are very, very important, and this is where the need of the hour if you want to utilize biomass to hydrogen. So I stop myself here. Thank you very much for your patience here.
Sir, thank you very much for the insightful lecture. I think it requires more time for a detailed presentation. Indeed, you have covered a lot of information. Thank you so much, sir.
Yeah. If you have any quick question, you can ask, otherwise in future I'll. Yeah. See, algae biomass as I talked, right? Algae contains around 80% of the water, right? So for algae, hydrothermal liquefaction is the better option. So by hydrothermal liquefaction, you can convert it into hydrogen. We are doing it at lab scale. So for that, the better thing is that if you convert this algae hydrogen, convert it into SAF, because a lot of this liquid, hydrothermal liquid would be there. This hydrothermal liquid has a lot of phenolic compounds, because algae is rich in nitrogen. So that is, either you do the denitrification of this, so that would be little bit costly. So we have utilized algae for the food product, because this is a vegan product and which is very important for the future. So this, we have isolated lot of series of the product from the algae through hydrothermal liquefaction. But you are very correct that if it is in the wetland area, that cannot be used for the vegan product. So then hydrothermal liquefaction followed by reforming. So that is a better solution compared to directly gasify, because or you use the solar method, dry the algae and then use it with the traditional biomass by pelletizing. So only thing that when you look at the density of the biocoal and density of the biomass, we are matching. So pellet design is very, very important. So because both can be used in the same gasifier. Right?
Sir, apart from that, so since agricultural waste is the main source for biomass production, but in the case of livestock, they are also dependent totally agricultural waste only. So how we will balance that in future, that for energy needs and that for nutrition for livestock?
No, that's what I said. This total biomass, if you look at the availability, it is more than 350 or 400 billion ton. And all the animal fodders, all the other 200 billion ton biomass is still available. Every year, if you look at the state-wise also, so UP, Maharashtra, these are the largest crop producers, right? And large amount of biomass in Haryana, Punjab, the same thing, around 200 billion ton of biomass per year, per crop is coming every day. Huge amount of bagasse is coming. Bagasse is presently used just as a power generation. But bagasse is rich in cellulose. And this can be converted even not only for hydrogen, but also SAF also. Because any fuel, any biomass which is rich in cellulose is good as a fuel. Lignin has some issue. So paper, and we are using the pulp and paper lignin, but that is good for phenol products, because lignin is rich in phenolic compound. Algae biomass, because it is rich in nitrogen, so the final fuel may have a NOx issue. So that's why I told that you have to find out either reduce it or convert it into a vegan product, which is again a very, very important. And even this algae, this hydroxyapatites are being made, which is for the bones, fillers as a bone product. Magnesium hydroxyapatite, calcium hydroxyapatite. If you add magnesium hydroxide, calcium oxide during the hydrothermal, you will get this solid product. So thank you.
Thank you, sir. During the panel discussion, many questions can be answered. And our next presentation is by Mr. Chandan Sahani. He is the head of advanced engineering, Tata Motors, Pune. Mr. Chandan Sahani leads the development of powertrain systems for electric, hybrid and fuel cell commercialization vehicles at Tata Motors Engineering Research Center. Prior to this, he headed the electrical and electronics design division for all the Tata Motors commercial vehicles, and he held various senior positions at the Tata Motors. May I request Mr. Chandan Sahani to kindly take over. Thank you.
Yeah, good morning, everyone. So I'll first of all, I think thanks to the DST team for inviting us and giving an opportunity in terms of how we can share what exactly is the perspective of the industry. So I'll give a slightly different picture in terms of whatever Dr. Padhi and Dr. Pant had shared in terms of the technologies. This is not really on technology, but in terms of the overall approach. Whatever we just heard in terms of solar power being so critical, or the methods of generating various forms of hydrogen is so important. But how do we look at from an industry perspective that, because all what we heard is required, but it is required in a way that it is commercially viable. I'll give a perspective in terms of how we are looking at automotive industry. And when we see ourselves as an automotive industry, I'm not saying only as a vehicle manufacturer, because we work with so many ecosystem partners. So whether it is our partners, whether we ourselves, or whatever we generate. So when I say what we generate, so we produce vehicles. Now vehicles, when they are on the road, they run on fossil fuels, they run on different kinds of fuels. So they themselves generate emissions. So the target as an industry, what we have taken is a net zero. It is not only scope 1, it is also scope 2, scope 3, so which is in totality, how do you not only become, say, self-sufficient in terms of how the energy resources are being managed, but also in terms of safe disposal and essentially a net zero kind of approach. So I'll give a brief in terms of how we have been looking at it. So essentially what I would like to quickly cover is why do we need a change. It's just a small video. I don't know whether audio would play or not. When we were looking at from an industry point of view, and we as a Tata Group, you know, Tata Motors is not the only part of the group. Group does pretty much everything you can think of. So as a Tata Group, we have taken a challenge of 2047 being group as a net zero. So you can imagine as a overall operations being net zero, pretty much everything in terms of overall energy resources as well as the disposal gets considered. How we can lead from India in terms of this change for the climate. There are a lot of commitments which are given, because when we look at automotive industry is very, very regulatory. You cannot have anything which is on the road but not complying to some of the regulatory needs. So whatever we plan, there has to be a global engagement in terms of how, as an automotive industry, we are looking at achieving these kind of targets, and what are some of the actions. So I'll just quickly try to play. I don't know whether we'll get some audio, but this is what we are looking at in terms of this is a World Economic Forum. When we started our internal journey in terms of why net zero is so important, this was one of the theme in terms of if we don't do it, what would happen decades over decades. So what we have done is mapped each decade. Sorry, the audio is not playing, but what happens over each decade in terms of things getting out of control. And we are already in 2024. So if we have taken a task of another 22 years or 23 years, in terms of everything to be ideally net zero, not as a nation but as most of the industries, then there needs to be a very, very critical approach in terms of how the temperature has to be still kept below 1.5 degree, and so many other opportunities which need to be taken into account. So you can see pretty much everything you can see, whether it is on road, whether it is on water, everything will get aligned in terms of the approach what industries take. And if you don't take action, these are some of the pitfalls which would happen in terms of many things which we see today not even being available. So this is just a context setting in terms of why whatever we have been discussing, whatever technologies are being talked of, why those are so critical in terms of their relevance and the need to actually make them available now, and all the actions which are required need to happen. So if so I'll quickly move forward. So I think we briefly touched upon the SDG goals. So these are essentially in terms of how we are looking at the UN goals, overall 17 goals, in terms of what actually classifies as a sustainable development. And in India, we have Niti Aayog looking at pretty much all of these 17 goals. So when we talk of automotive, we talk of any industry, you have to look at holistically the entire picture. It cannot be just handling one of the say elements as part of overall sustainability goals. So as part of our journey, we are looking pretty much at all 17 in terms of wherever we can play our role. Of course, there are elements which are very specific to automotive, but pretty much we are trying to address all of them, because holistically that can actually help us achieve the SDG goals much faster. In terms of why we have an opportunity as a nation in terms of leading the global initiative. So this is a roadmap in terms of how as a nation we are looking at achieving the goals by 2047. So in terms of some of the actions of reducing the emission intensity, how the 50% of the electric power capacity can come from non-fuel or non-fossil fuels, how we can have the technologies which can lead to carbon sink, and thereby some of the activities which are short term, some are slightly higher term. So this is how, if we have to go step by step as a nation in terms of short term, mid term and long term, some of the activities which are there for this decade till 2030, then 2040 to 2050, and then beyond 2070. So these midterms could be introduction of electric vehicles, using more efficient systems, or in terms of using hydrogen as a choice of fuel 2040 onwards, when it will be sort of commercially viable in terms of what it can lead to. So this is like in terms of if we have to look at the nation's goal for 2070, how it can be achieved. Now in terms of most of the industry, if you see, there are three pillars what everybody is looking at. It is actually in terms of how do we drive the net zero in terms of the overall the energy consumption. So that is one pillar in terms of net zero. The second pillar is the circular economy. Circular economy is very, very important because that's a basis in terms of how you can actually go about and achieving a complete positive feedback in terms of the closed looping. And then very, very important topic where we are very, very say actively engaged, and so are our other industrial partners, is the preserving nature and the biodiversity, because you cannot have full circular economy if the biodiversity is not sort of thought of. So these are the three pillars basis which all our activities are aligned, and like I said in the beginning, all this has to be done in a way that you can actually produce something which is commercially deployable and people can actually buy those vehicles. So all these technologies finally go into the vehicles. So just to give you an example, some of the plastic parts in the vehicles, eventually now we are looking at some of the disposables from the sea. So there are a lot of say reusable parts which are now getting into vehicles, which actually enhance the life by many years. Going forward, so if we were to look at how automotive industry is looking at achieving the targets, so there is a global organization called as SBTI. So that's basically Science-Based Targets Initiative. It's a global organization, consortium of a couple of companies. They actually engage with the industries. Now, basis their engagement, there is a scientific method in terms of how companies can keep producing a set of vehicles which eventually will lead to a progressive say decrease of the overall carbon emission and eventually hit the road of 2047 as net zero. So in terms of very, very specific science-based approach on producing the vehicles, this is one approach most of the industry partners are taking on the SBTI. So this organization actually audits independently. They give a lot of inputs in terms of what should be your portfolio mix, how much of vehicles you can keep on producing for, say, your regular fossil fuels, what level of penetration you should have for electric vehicles, what level of penetration should be there for hydrogen vehicles, LPG, CNG. So this is an independent evaluation, and that gives you a scientific way of managing that from 22 to 23 years from here on, what should be the approach so that when you actually hit 2047, you are actually net zero. So it's a huge task, because today if you see, most of the vehicles are still very, very focused on fossil fuels. The target of 30% penetration of electric vehicles by 2030 also is not there. We hardly have not even 5% today. So these are some of the companies which are part of that overall approach, and they have actually formed SBTN, which is the network of science-based targets initiative. So as an industry, this is one approach in terms of how this is being addressed. Now, this is an important area in terms of looking beyond what we produce. So if you see scope 1, scope 2, scope 3, this is essentially so scope 3 is what we finally produce, which is the vehicles. And when vehicles on the road, they have their own set of emissions. So how do we control scope 3, which is the vehicle's emission? Then as we produce vehicles, we ourselves consume so much of energy, which is your scope 1 direct. So as an organization, as an industry, you create so much of emission, which is like a net zero. So scope 1 is an immediate target. So whatever we heard in terms of hydrogen being available or the solar power, this is all getting incorporated as we speak in terms of whatever energy we consume today as an industry. And scope 2 is basically when we work with our channel partners who produce parts for us also need to be net zero. So we have a huge task, not only for us, but the entire ecosystem. And this is what we have as Tata Group, but also in terms of how our other industry colleagues are doing. So overall it leads to much better coordination within the industry partners. So these are some of the research areas in terms of where we are very, very actively working in terms of how do we actually look at net zero, and what I had shown in the earlier slide, 3 pillars. As part of the earlier slide also, what you see on the extreme right is the vehicles we produce, then what we generate and consume as energy, and then our ecosystem partners. So it's a more quantitative version of the previous slide. Now, if you were to look at overall as part of, say, emissions, automotive today contributes to around 13% of the overall emissions. So our target is set out in terms of what we have to contribute as an overall net zero closure in terms of what we contribute. And within that 13%, if you see the bottom one, the domestic aviation, roads, rail, pipeline transport, and the domestic navigation. These are some of the areas where we have the availability in terms of the mix. So the task is cut out in terms of how we contribute this 14%, what automotive today contributes. So if we were to look at the overall pathway, so this is where we are pretty much today. By 2030, this is how we will move. So if you see, the target was around 5% of electric vehicles in 2020, which has not happened. The target was to still go down in 2030, and so on and so forth for so many other initiatives. So essentially what we are looking at is beginning from 5 years prior till 2050, we have actually mapped all the targets in terms of what should go down, what should be neutral, and where we have new initiatives taken up. So if you see the target of 2050, it is very, very clear in terms of the 4 major contributors which are there today for emissions. Mainly when I say emission, it is the carbon emissions, how they can be mapped in terms of the various action points. So this is again data driven together with the SBTI, which I had shared earlier. So there is a very, very scientific way in terms of how all these 4 pillars would be addressed, so that the net zero target of 2050 is achieved in pretty much next 2 decades. So going specific to the technologies which are there in the vehicles, so whether it is the battery technology, hydrogen technology, the driveline technologies, or the vehicle platforms, or the alternate fuels. So coming very specific to, very quickly to battery technology, we are looking at higher energy density, because that will give you more efficiency in the same form factor. Alternate cell chemistry, sodium ion is something which is actively being looked at, and improved thermal management. So these are some of the areas we are looking at in battery, very specific to automotive application. We are looking at introduction of hydrogen-based vehicle, whether it is H2 ICE or fuel cell vehicles. So there are a lot of initiatives from government as part of MNRE initiatives. So we have a challenge today on hydrogen availability, but that's something is being managed. And then the last one, what you see is the BOP localization, which is balance of plant. So balance of plant is whenever you have a hydrogen-based engine, there are, say, auxiliaries which make it work. So localization of that. So these all improve efficiency. These all improve the availability of parts locally in India, and thereby would contribute to overall net zero. In the driveline technologies, again very specific to electric vehicles, the advanced topologies looking beyond PMSM, the magnetless motors and some of the other technologies, higher efficiency drivelines. There is a new category of axles, lightweighting of the aggregates because it improves the overall efficiency. Then there are born EV platforms which are being thought of, which would be much, much more efficient and lighter in weight, and a concept of hybrids. And the last one is important, what we heard from the other 2 speakers also, biofuel, LNG, and there is a fusion of CNG and hydrogen, ethanol blending, bioethanol. These all are to be used in a way that these are commercially viable, and then it is not only as a fuel, but the vehicle based on those fuels also has to be viable. So there is a lot of effort being done on these areas. So very, very high level, this is how we are looking at transition of the fuels. So what you eventually would see 2040 and beyond would be electricity and hydrogen. Pretty much everything has to end on what you have today by 2040. And this is the current trend. In spite of all the initiatives, what you would see, diesel, petrol, it will keep on increasing for another 8 to 10 years. and then they finally die down around 2060 or so. So this is a huge challenge because it is not question of what we produce or what we try to sell. The consumption from the end customer is not sort of there in terms of the pull. So this is a very, very worrying figure in terms of, in spite of all the efforts, the current trend of conventional vehicles will keep on increasing for a while, and thereby puts more effort in, more initiatives are required to counter the higher penetration of such vehicles. So this is what we are looking at as an industry input. So this is an important slide in terms of, I think we briefly discussed in the morning session on how the batteries can be used. So there you can look at what we use today in vehicles is the first one, where pretty much the entire installed capacity is there. So when the installed capacity goes to 80%, meaning you are left with 80% of the install, it goes to second use, which is some of the say second use in terms of the grid applications. So grid balancing is one of the areas how batteries can be used. So that's the second use. When it goes to 30-35% of that capacity, then it has to go for a natural recycling. But you can imagine if all the batteries which are today used in vehicles were to be scrapped after the 80% use, then there will be huge landfill in terms of how to accommodate those batteries. So this approach of reusing some of the second life applications is important, and since as Tata Group we work very closely with Tata Power, which is the major energy producer in the country, we have a very good linkage in terms of how batteries can be used. And I think in your presentation, it is not only question of using battery. I think batteries for grid needs a different kind of treatment as a categorization of the battery management system. Maybe we can discuss that. So we have worked certain customization for Tata Power in terms of how, because you need, the vehicle would run and stop and then it would get parked. But for the grid you need continuous and for a very high discharge rate. So there are certain customizations. So when we sell the vehicle battery for the second use of power, we do some customization. It is not a straightforward. V2G, yes. But today the application is limited. We are just as a gap filler. Before it becomes a mainstream, I think we are a while away. Correct. Right. So these are some of the what you see on the right hand side: advanced chemistries, renewable energy powered, then the supply chain where you can have more of reusable and recyclable parts, and designed for improved efficiency and the reusability of the battery. So this is how we are looking at the sustainability implementation in some of the automotive applications. This is a very specific example of what motors we use in electric vehicles, what are we doing to see that they are economical and sustainable. So whether it is the winding of the motors, the lamination, or in terms of the magnet or the thermal design, lot of efforts are being done in terms of how we can have a much better torque density, much better power density, and there is a recyclability and reusability of most of the critical child parts so that we can extend the life and have lesser consumption in terms of what is required to produce those parts. So we are trying to address battery, we are trying to address, in electric vehicle motor is pretty much your engine. So these two key areas are getting addressed. In terms of hydrogen, very specific to what we are looking at in automotive, I think these are some of the areas. Green hydrogen is being actively looked at, so we work very closely with IOCL and some of the other organizations to become a source of green hydrogen. Now green hydrogen of course has a challenge in terms of what purity you need, and not only purity, but you need to have sufficient vehicles for an electrolyzer based setup to be really economically viable. So that's an area we are looking at. So hydrogen we have classified in 3 areas. One is the generation. So once you generate, you need to store, and once you have stored, you need a good method of transportation, because you cannot have a approach of generating hydrogen storage units everywhere. So transportation for hydrogen, which is a logical problem, that also has to be looked into. So the cryogenic solutions are also being looked at, and the tube trailers. So today we are at 700 bar, which is just to get certified, but people are already looking at 900 bar, 1100 bar, which will improve the so I'll just quickly finish. This is again something, lot of work happening on the hydrogen in terms of the specific materials, whether it is the catalyst and some of the other BOP parts which are being looked at, how the hydrogen can be very, very relevant. This is another area in terms of how circular economy is being looked in automotive. So this is the state. On the left hand side, what you see is what happens today. You take inputs, you use, and it goes as a scrap in terms of the landfill. The reusability of those parts actually gives you a circular economy. So that's an area which is being worked about. So a lot of work happening here. This is again in terms of how circular economy, not only for the direct material but for the indirect material, would be utilized. So this is a very, very active area, and what we have found that this actually not only gives you a lot of alternative ways to manage what you consume, but it is actually very, very economically viable. So overall, if we were to summarize, there are just 2 more slides. As an industry, these are the 4 focus areas we are looking at our design and development, the way we produce vehicles, the operations, the after-sales service, and the supply chains. And then there are specific activities which are linked for sustainability on each of them. And together, that gives us the pathways for overall circular economy. This is again in terms of biodiversity. I think this is a topic which is not very often discussed, but we are very, very actively engaged in managing the biodiversity also, because when we start consuming something from the nature, it has to be closed loop in terms of giving it back. So there is a lot of efforts happening on the biodiversity, and those are again based on science-based and the nature-based solutions. So this is again the set of organizations which are working together like our as Tata Group. And finally, where this was, I think, again a COP29 where nothing much happened, but I think there is still some of the positives to be taken away. Last slide, if you were to look at, again, this is the transition we are looking at. So this is the last slide in terms of what we have found out, that it is not an additional burden in terms of looking for sustainability. When we started actually this journey a couple of years back, what we have found out, it has actually helped us in terms of so many new solutions which were actually giving us a lot of commercial benefit also. So whether it is renewable energy, usage of water, we are actually going to be water positive in our operations in 2 to 3 years. Strategic approach, commitments, circularity, and the overall supply chain in terms of how do we manage our partners, and keeping nature as central to all this. So these are the 10 pillars where as an industry we are looking at, and we are finding good traction, and very confident that whatever targets we have set ourselves as an industry for achieving these goals, that should be viable, and the entire ecosystem can be managed. So thank you.
So thank you very much. It is an important subject, electric vehicles and circularity. Thank you, sir, for insightful lecture. Can we move to the last panel lecture before we go for panel discussion? The last lecture is by Madam Rupa Bhatti. She is an architect and adjunct professor at Institute of Advanced Sciences. She is an Indologist and into sustainable and vernacular architecture research. She is presently engaged in authoring 2 books, namely Tale of 3 Cities and the Agastya Code, which are based on archaeoastronomy and other sciences. She is researching various facets of Indic scriptures with the context of various sciences to help understand the history of archaeoastronomy, anthropology, geology, geography, climatology, etc. May I request Madam to take over. Madam, kindly keep the time within 10 minutes.
I should now say good afternoon. So I'm quite overwhelmed to be present here, and to all the dignitaries who have come here, and the listeners. Okay, can this be a little louder? Is it okay now? Fine? Yeah. So, my pronouns to all the dignitaries over here and my love to all the children who are listening to me today. And I'm honored to be present here.